Dissect or fundamental loop matrix. For a given tree of a graph, addition of each link between any two nodes forms a loop called fundamental loop or dissect. Matrix B denotes dissect matrix or loop incident matrix, and the dimensions are L cross B, where L is the loops, links, and B is the branches. The L is given by B minus n plus 1. B will be having an entry of Bij equals to 1 if branch Bj is in fundamental loop Li and reference direction coincide. Bij equals to minus 1 if Bj is in fundamental loop Li and reference direction are opposite. Bij equals to 0 if branch Bj is not in fundamental loop Li. Since it is a fundamental loop, you consist only one link. A loop direction is same as link direction. Let us consider this graph having 4 nodes A, B, C, D, namely, and branches 6, that is 1, 2, 3, 4 up to 6. The number of 3 branches or twins is given by n minus 1, that is 4 minus 1, that equals to 3. And the links L is given by B minus n plus 1, that equals to 6 minus 4 plus 1 equals to 3. Let us draw a tree for this. A, B, C, D, 1, 2, and 3. These are tree having the branches 1, 2, and 3. Links 4, 5, 6. And if I add 4 to tree 1, 2, 3, then this is A, B, C, D, 1, 2, and 3. So we have a fundamental loop, let it be L1. So loop 1, 1, 4, 2, where 4 is the link. If I add the second link, that is pi to 3, 1, 2, 3. A, B, C, D, and addition of B. Now the L2, that is fundamental loop 2, is given by 5, 3, and 2. If link 6 to be added to 3, loop 3, that is fundamental loop 3, is given by 3 and 6. Now we got 3 loops. Loop incident matrix or dissect matrix B is given by the loops and the branches. We have 3 loops, 1, 2, 3, namely 1, 2, and 3, and branches 1, 2, 3, 4, 5, and 6. If we consider loop 1, we have 4 to 1, and the direction of this loop is along the link direction, that is along the 4. So 4 is always a 1, and 2 is in opposite direction, so minus 1, and 1 is the same direction, 1. And 3, 5, 6 are not incident in the loop. Second loop, the direction of this loop is along the 5th branch, so 5 is always positive, and 3, 2 also present, where 3 is in opposite direction and 2 is in the same direction, and 4, 6, 1 not present in the dissect or in the loop. And loop 3, in which 1 is not present, 2 is not present, 3 is there. What about the direction? Direction is opposite, and 4 is not present, 5 is not present, and 6 is there, that is link, so it will be positive always. This is our dissect or fundamental loop incident matrix. Now KVL can be applied to fundamental loops to get a set of linear independent equations. Now assume that the loop 1, that is I1, and the loop 2 is I2, and the loop 3 is I3. If 1 to 3 are V1, V2, V3 branch voltages. Now, KVL equation for the loop 1 is given by V1 in the same direction of I1. So V1 plus V4 minus V2 equals to 0. Now for the second loop, V5 minus V3 plus V2 equals to 0. V6 minus V3 equals to 0. Now let us try to write these three equations in matrix form. Then we'll be getting I1, I2, I3, V1, V2, V3, V4, V5 and V6. The first V1 is present, V2 is minus 1, 0, 1, 0, 0. The second one 0, 1, minus 1, 0, 1, 0, 0, 0, minus 1, 0, 0, 1. This equals to 0. This is nothing but matrix B, tensor matrix multiplied by branch voltage VB equals to 0. Tensor matrix and branch currents. If IB represents the branch currents and IL represents loop currents, branch currents IB is equals to transpose of tensor matrix multiplied by the loop matrix. Branch currents IB is given by I1, I2, I3, I4, I5 and I6. That equals to beta transpose. And the IL, we have IL1, IL2 loop 2, IL3. Now this is a graph with the loops and links and branches. Now calculate this. I1 equals to first one IL1 and I2 equals to IL2 minus IL1. I3 equals to minus of IL2 plus IL3. I4 equals to IL1. I5 equals to IL2. I6 equals to IL3. The current in branch 1 is nothing but IL1 only. In branch 2, it is IL1 as well as IL2. Both are in opposite direction. One is positive and another one is negative. And I3 is the branch 3 current. Both are in opposite direction to the given direction. And I4 is again IL1, I5 IL2 and I6 IL3.